We are now going to write equivalent equations with the goal of making it easier to use the quadratic formula. So we're going to start with an example of minus 2x squared plus 5x minus 4 equals 0. And the problem with this equation is that we have an a that's negative. So what we want to do is multiply both sides by a negative 1. When we distribute, that gives us 2x squared minus 5x plus 4 equals 0 times minus 1 is still 0. And so now it's going to be easier to use the quadratic formula because our a is positive. As another example, suppose we have x squared plus 4/5 x minus 1/3 equals 0. Here, we don't want to use fractions in the quadratic formula if we can help it. So we're going to start by finding our LCD, which is 5 times 3, 15. Multiply both sides by 15. Gives us 15x squared. 15 divided by 5 is 3 times 4 is plus 12x. And 15 divided by 3 is 5 equals 0. Now we have something that will be easier than before, and it's an equivalent equation, so it'll be solved the same way. As another example, suppose we have 5x squared minus 15x minus 10 equals 0. Here, we're going to go the opposite route. We're going to find the GCF, which is 5, 3 times 5, and 2 times 5, so our GCF is 5. So we're going to divide everything by 5 to make our numbers smaller, including the 0. So 5x squared divided by 5 is x squared, minus 15x divided by 5 is minus 3x, minus 10 divided by 5 is minus 2, and 0 divided by 5 is still 0. So again, we've created a new equation that's going to be easier to evaluate because the numbers are smaller. And our last example, if we have decimals, 0.06x squared minus 0.08x minus 0.02, too many zeros, equals 0. Well, as we're looking at this, we notice that we can get rid of the decimals by multiplying everything by 100. That'll move all of our decimals 2 places, which will give us 6x squared minus 8x minus 2 equals 0. And we can go a step farther here. Notice that there's a GCF of 2. 2 goes into all of those numbers, and it goes into 0. 3x squared minus 4x minus 1 equals 0. And we've now simplified our equation so that it's easier to use the quadratic formula on it. So when you look at problems, you want to make sure that you have a positive a and that your numbers are as small as they can be without becoming fractions.